Here, if you look at the output in that SPSS, you see this is the multiple regression. This 12.96 actually always the standardized coefficient of the dummy variable. That unstandardized coefficient of dummy variable is a difference in outcome variable between the two groups. The outcome variable here in this example is systolic blood pressure. This is a difference in systolic blood pressure between male and female when the age is controlled, when the age and this interaction is controlled for. All right. So we have that number. So this is the again difference in systolic blood pressure between male and female when we control for age. Now, I can give you also, look at the systolic blood pressure. We already have the systolic blood pressure in our data set. Okay, go back to the data set. We have the systolic blood pressure. We have this group, male and female. We can calculate what is the mean of systolic blood pressure for male, what is the mean of systolic blood pressure for female, and is there a difference between the two means? You see, we have that systolic blood pressure, and we have this category 0, 1. So this is an example of t-test, it's a two-sample t-test. So I run that. I click on Analyze, Compare Means, Independent Sample t-test. I move the systolic blood pressure as a variable, as a test variable. Sex goes to grouping variable. So you have two question marks. I have to take care of those two question marks. So I click on Define. I know I have one value 0, one value 1. This is the dummy variable x2, or we call it sex here. So I click Continue. You see I have 0, 1 there, and I click OK. And that's give us a SPSS output. As you see here, you see the mean systolic blood pressure for female is 139, almost 140, and then for male is 155. So there is a 15-point difference between the two, which is, you can see here the difference is 15. This is exact difference, 15.288. Now, why over there, as I said, difference? Why is 12 here? Here is 15. The reason is 12 here because that number is adjusted for age. That's the idea in multiple regression. I mentioned that many times. In a multiple regression, we only concentrate on the marginal contribution of each variable, not absolute contribution. Absolute contribution of variable only is possible if there is zero correlation between this variable, which is very rare. In the real world, never happens. So as long as there is some correlation between these variables, their marginal contribution would be way different from the absolute contribution. The more correlation between these variables, the little marginal contribution of each variable. So again, here is 15, 288, but it's 12 here. One other thing is, you see here is that difference, is 12, almost 13 point, is not significant. But when you look at the t-test, you see we have a significant, highly significant. In other words, these two differences, this 15-point difference in systolic blood pressure between male and female is highly significant. Now, we can generate, or we can find this exact value using multiple regression. If you move the age out of regression, only run a regression as a systolic blood pressure as a dependent variable and sex as independent variable. And then we will see exact this number shows up. You will see. Here, if I click on Analyze, and then Regression and Linear, at this point, I'm going to remove that, actually remove the sex and put the sex back. Only have, see, I have systolic blood pressure as a dependent variable and sex as independent variable. All right. So this is a simple regression, one dependent, one independent variable, and that independent variable is a dummy variable. So, and it's fine as long as the 0, 1 dummy variable is allowed in the regression. So I click OK. Again, I'm going to, this is for t-test we had. I'm going to get rid of, until I get to the coefficient. Okay, here. This is a regression, and this is a simple regression I was talking about. You see the dependent variable is systolic blood pressure, the independent variable is sex, and look at that coefficient. It's 15,288, exactly the same. The reason it's negative here because the computer in t-test wrote 139 minus 155, so that's why you get negative. But look at the absolute value, exactly the same. So again, if the dummy variable is only variable in your regression, the coefficient, the unstandardized coefficient on that regression for dummy variable is a difference in the mean of that outcome, whatever outcome you're looking for. Here is systolic blood pressure between the two groups. Here, the difference in mean systolic blood pressure between male and female is 15.288, and then represented by that unstandardized coefficient of this dummy variable. Now, in practice, we rarely use that interaction term in the dummy variable. We use that interaction in order to show you how to find the two lines. But sometimes you don't need to do that. You want to find out how the groups are different based on that response variable. In other words, you want to see how the groups in this example, male and female, are different in terms of their blood pressure. And then you only use one dummy variable here because of gender. And then as you see, this is highly significant. And that t-value is exactly identical to that p-value here, you see. Exactly the same t-value. And then p-value, of course, the same. So again, these are a lot of similarity between the two t-test and the multiple regression, if only that independent variable is a dummy variable. So actually, instead of t-test, you can run a simple regression with your response and your group as an independent variable. Okay, that's conclude our lecture on dummy variable at this point.